All right, remember the other day when I told you that when you use your calculator, go up in the upper right corner, make sure you hit degrees, not rad, because rad will give you the wrong answers. Well, today I'm going to tell you what that rad stands for, and that rad stands for a radian. A radian is another way to measure an angle, and it's helpful because it's a length measurement, and so a lot of times we can do more with a length, which is in our standard measure units, versus a degree. All right, so I'm going to explain to you how a radian is defined. All right, so if I draw a coordinate plane, and then you're going to have to excuse my lack of being able to draw a circle, and I draw a circle with center at the origin. If you think about this, then each one of these from here to here is a radius, right? So if I want to define a radian, what I'm going to do is I'm going to say I had a piece of string, and I take my string, right, or say, because I need something that bends, a pipe cleaner or anything like that, and I measure from here to here. So I measure the length of the radius. Then I'm able to take that string, or I'm able to take that pipe cleaner, and I'm able to put that radius along the edge of the circle and mark where it ends. So if you think about that, then the length from here to here is R, but also the length from here to here is R, right? And if I connect this point to this point, the length from here to here is R. All right, the angle formed in here is being defined as 1 radian. So the angle, 1 radian angle, is equal to the angle that's made by making an arc of length R. All right, so the definition of a radian is 1 radian is the measure of the angle in standard position. That's important, actually, that we're talking about angles in standard position, because that's why when we're in geometry we use degrees, because we're not really talking about angles in the coordinate plane, whose terminal side intercepts an arc of length R. So my terminal side here intersects this circle so that this arc has length R. All right, so depending on the size of the circle, or depending on the size of the radius, right, that is going to be at different lengths. All right, let's think about this a little bit more. What is the circumference of this circle? All right, the circumference of this circle is 2 times pi r, right? So going all the arc, if I were to measure that arc with a piece of string all the way around here, it'd be 2 times 3.14 times r, approximately. So another way to think about that is 360 degrees in angle measure is equal to 2 pi r in arc measure. If I divide both sides by 2, I get 180 degrees is equal to pi times the radius. All right, and then if I divide both sides by r, I get pi equals 180 over r. Actually, I want to do it that way. let's go back here. So if the circumference is 2 pi r, then I know that the radian measure of the circumference is 2 pi, right? It takes me 2 pi to go all the way around there. So there are 2 pi radians in a circle. All right, so if there's 2 pi radians in a circle, that's equal to 360 degrees. If I solve for pi, I get pi radians is equal to 180 degrees. Okay? So if we were measuring degrees, we would say 180 degrees is pi. 90 degrees then would be half of pi. This would be 0 radians or 2 pi radians. And this would be 3 pi over 2 radians. If you look at your guided notes on the second page, I've given you a chart that shows the conversion of our common angles to radians. So 30 degrees is pi over 6, 45 degrees is pi over 4 radians, 60 degrees is pi over 3 radians. All right? All right, because we know that pi radians is equal to 180 degrees, then we're going to use that as our conversion factor to be able to switch from degrees to radians. All right, so to convert from, if I'm going from radians to degrees, I'm going to multiply my angle by 180 over pi radians. Right, if you think about that, I'm only multiplying by 1 because those are equivalent. So the radians are going to cancel out, and that will leave my answer in degrees. If I start with degrees and I want to go to radians, I'm going to multiply my angle by pi radians over 180 degrees. All right, so if I do an example, if I have negative 150 degrees, to convert it to radians, I'm going to multiply it by pi radians over 180 degrees. So I get negative 150 pi over 180. If I simplify that down, I get negative 5 pi over 6 radians. All right, so again, if you look at this chart right here, if we go a negative 150, we're going negative 90 and a negative 60. So we go a negative 1626, 3646, 56. Okay. All right, let's do another one. Let's say we start with 135 degrees. So if I have 135 degrees and I want to convert it to radians, so I get 135. I'm going to put the degree symbol and the radians in at the end so that I can just do the math. So if I simplify that down, that comes out to be 3 pi over 4. And then I'm going to write radians so I know. All right, if we start with radians and we want to convert it to an angle, so say for example we start with 9 pi over 4, we're going to multiply that by 180 over pi. Pi's are going to cancel out. Let's say 4 goes into 180 45 times. 9 times 145 is 405. So I get 405 degrees. Another example would be 5 pi over 2. I would multiply that by 180 over pi. So cross out the pi's. 2 goes into that 90 times 5 times 90 is 450 degrees. All right, we're gonna review again radians. So what we should know now is the definition of a radian, that a radian is the angle that's formed. If I make an arc here, that's the length of the radius. All right, that defines how wide to make this angle. I measure from here up, I measure the length of the radius, and then I draw my terminal side, and that gives me that angle, and we call that 1 radian. All right, all the way around a circle is 2 pi radians. Halfway around the circle is pi radians. We have the conversion factor because 180 degrees is the same as pi radians. We use that either in this form or its reciprocal to change radians and degrees. And again, why we want to do this? Because in some problem solving, we want to be able to use the same units of length. So we want to be able to express our angles in terms of length.